Hello calculus learners, in this video we're going to talk about how to figure out horizontal asymptote and the vertical asymptotes, okay? So first of all, horizontal asymptotes can be found by taking the limit of the function as x approaches infinity or negative infinity, okay? So whatever comes out of that limit is going to be our horizontal asymptote. So the way we express the horizontal asymptote is going to be equal to y equals a number line. Okay, so let's say when you take the limit of this f of x function as x approaches infinity and the result is b, that means that b is going to be our horizontal asymptote and also the limit of this function. So the y equals b are going to be our horizontal asymptote equation. Okay, so let's move on finding the vertical asymptote. So vertical asymptote occur when denominator of the rational function goes off to 0, okay? So whatever makes denominator equal to 0, then it's going to be our vertical asymptote. The way we express vertical asymptotes is going to be like this: x equals a number. So let's say we have this f of x function. F of x equals x cubed over x minus 2. So there's only one thing that makes this denominator go to 0, which is 2. So when you set this denominator equal to 0, x minus 2 equal to 0, so we get x equals 2. So when you substitute this x equals 2 back into the function for the denominator, we're going to end up with 0 for the denominator, and it's going to also make the entire function go undefined. So which means x equals 2 lines are going to be our vertical. Move on to the examples. So in these examples we have problems 1 through 4. So and then they have 4 parts. So in part A we're going to find the limits of these functions as x approaches infinity. In part B we're going to find the limits of these functions as x approaches negative infinity. In part C we're going to find the horizontal asymptotes. And in part D we're going to find the vertical asymptotes. Alright, so let's specifically focus on question 1. In question 1, part A, we're going to find the limit of this function as x approaches infinity. But before that, I would like to make a simplification. Okay, so if I factor out of x, which is the biggest common factor for the top, so we get 2x squared minus 9x and plus 4. And if I factor out of x, same thing for the bottom function, so we get negative 3x squared plus 6x plus 24. Okay, and if you may have noticed that I can simplify this x's, okay, and what I'm going to be left with only x approaches infinity 2x squared minus 9x plus 4 over negative 3x squared plus 6x plus 24. And notice that we're taking the limit as x approaches infinity, and then we are, we ended up with this rational function. Top and the bottom are both polynomial. So that's why in this case I need to look for the highest degree of the top function and the highest degree of the bottom function. So the highest degree of the top function is x squared, the highest degree of the bottom function is x squared, which means they got the same degree. Remember the first case, if the degree of the numerator is equal to the degree of the denominator, then the limit is going to be equal to the ratio of the leading coefficients. So what are the leading coefficient of the top function? Which is 2. The leading coefficient of the bottom function, which is negative 3. And when you take the ratio of them, you get negative 2 over 3 as the limit of this function. That's part A. And part B, I'm going to take the limit of this function as x approaches negative infinity. Since the degrees are equal to each other, then the limit is going to be equal to the same thing, which is negative 2 over 3. In part C, it says find the horizontal asymptote. Since we figured out the limit of this function as x approaches infinity and also negative infinity, we also found the horizontal asymptote of this function, which is negative 2 over 3. So horizontal asymptote at y equals negative 2 over 3. And part D, we are supposed to be finding the vertical asymptote. So if I want to find the vertical asymptote, I need to set the denominator equal to 0. So what I mean is negative 3x squared plus 6x plus 24 has to be set equal to 0. So once we we need to set it equal to 0. Or we can also rewrite this function, the original f of x function, into like this. F of x equals 2x minus 1 times x minus 4 over, so this is the factored form of the top function. And let me rewrite the factored form of the bottom function, which is x minus 4 times x plus 2. And notice that this x minus 4's are the common factor, so we can simplify. So when I simplify that, what I'm going to be end up with only 2x minus 1 on top and x plus 2 on the bottom. So if I set the denominator equal to 0, which means x plus 2 equal to 0, so we get the vertical asymptote, which is x equals negative 2. Okay, that's the question 1. Let's move on to the question 2. In question 2, we're going to do the exact same thing. So we're going to be finding the limits when x approaches both infinity and negative infinity. Okay. Part A, limit x approaches infinity, f of x is going to be equal to just, in this case I'm going to look at the end behavior. So the end behavior of the top function is just 2x, okay, and the end behavior of the bottom function is, divided by 4x, and the limit is going to be equal to just 1/2. Okay, that's part A. Part B, limit x approaches negative infinity, f of x. But in this case, x approaches negative infinity. So when it's approaching negative infinity, notice that at the bottom, the highest degree is 1, which is an odd degree. So when you substitute negative infinity, so we get, negative infinity at the bottom, okay? Like we're gonna get a negative number at the bottom, okay? And when you substitute a, negative number into this square root expression, it's gonna make it positive. So whatever we put it into the square function, it's gonna make it positive. So that's why we're gonna end up with positive divided by negative. So the ratio is gonna be the same thing, but the sign of the ratio is going to be changing. So positive over negative, which is negative. So basically the limit of this function will be just negative 1/2. Okay, and part C, it says horizontal asymptote. So which means, since we ended up with these limits, 1/2 and negative 1/2, which means this function has horizontal asymptotes at y equals 1/2 and y equals negative 1/2. All right. And part D, I'm going to put it right here, part D. When you set the denominator equal to 0, which means 4x minus 6 equal to 0, and from there we get x equals 3/2. So there is a vertical asymptote at x equals 3/2. Okay, and that's question 2. Let's move on to question 3. So we're gonna do the exactly same thing. Okay, so in question 3, we're gonna take the limit of question 3 when x approaches both infinity and negative infinity, finding the horizontal asymptote and the vertical asymptote. So part A, limit x approaches infinity, f of x is going to be equal to 0. Why? Because the bottom function is going to grow faster than the top function, so that limit is going to be equal to 0. Part B, limit x approaches negative infinity, f of x is going to be equal to the same thing, because the bottom function is going to be growing faster than the top function always. So basically, limit is going to be equal to 0. Then it's going to have horizontal asymptote at y equals 0, because we ended up with these limit values. And D, part D, we need to figure out the vertical asymptote. How do we figure out the vertical asymptote? The vertical asymptote can be figured out by setting the denominator equal to 0. So 8x cubed plus 1 equal to 0, and from there 8x cubed equals negative 1, and x cubed equals negative 1/8, and x is going to be equal to negative 1/2. So there is vertical asymptote at x equals negative 1 over 2. And that's question 3. All right, let's move on to question 4. All right, in question 4, we have this f of x function combining two functions like logarithmic function and exponential function. So the part A, limit x approaches infinity, ln x plus 2 over 6 to the power of x. So notice that the top function is logarithmic function. Okay, remember the hierarchy. The top function is a logarithmic function. The bottom function is exponential function. Okay, so which one has the greater growth rate? Of course, exponential function. So that's why the limit of this function is going to be equal to just 0. And part B, I'm going to do the part B a little bit different. So in this case, since we're taking the limit of this expression as x approaches negative infinity, what I'm going to do is limit x approaches negative infinity ln x plus 2 over limit x approaches negative infinity 6 to the power of x. So basically, when you substitute negative infinity for the bottom limit, so we're going to end up with 6 to the power of negative infinity. This can be written down as 1 over 6 to the power of infinity. So 6 to the power of infinity apparently is infinity. So what is 1 over infinity? So 1 over infinity is 0, which means for the bottom limit it is equal to 0, which means we have a limit value on top divided by 0, which means it's going to be undefined. Okay, the part B, when you take the limit of this function as x approaches negative infinity, we're going to end up undefined. Okay, so part C, this function has a horizontal asymptote at y equals 0 because of the first limit. And part D, we need to figure out the vertical asymptote. If I want to figure out the vertical asymptote, I need to set this denominator equal to 0. But notice that 6 to the power of x is always bigger than 0. So there is no vertical asymptote. So part D, there is no vertical asymptote. Why? Because 6 to the power of x is going to be always bigger than 0. Alright guys, thanks so much for watching this video. See you in the next video. Bye bye.